Welcome all for Unnati Education videos again. In the last video, we were discussing about uniform velocity, and then we have seen about position time graph and different situations. And then I promised you to teach how to find out average velocity from PT graph, position time graph. So before going to that, I will explain about something about graph that you should know in order to understand that part of the unit. Okay. So first of all, what I'll explain is about drawing graph. You know how to draw a graph. So suppose if two quantities are given, two physical quantities are given, we have to draw graph for that. For the time being, let us consider position time graph only. Position time graph. Okay, position, say I will represent a position as x and time as t. Position time. The values are given. Suppose the values are given. When the time is say 0, position is also 0. When time is 5 seconds, time in seconds, okay, say position in that is meter, position is 5, say 5 meter, and then when time is 10 seconds, position is 5 again, position is say 10, okay, 10 10 meter. Suppose if I draw a graph for this position time graph, position time, along y-axis I will represent position, along x-axis I will represent time. If it is so, how I can draw the graph? So before drawing graph, any graph, what we have to do in graph sheet while we are drawing, we have to choose a scale. What is that scale? Not that instrument. It is not instrument scale. What we have to do is we have to choose a scale, that is in x-axis and y-axis, what are the values we are representing. That scale we have to choose. So that means there will be several divisions like this, right? 1 centimeter divisions there will be in graph, right, like this. So what is the value of this length that we choose? That is what you call as scale. Okay, so how to write a scale means, here you will write a scale that is we have to choose like x axis, in x-axis we have to choose 1 centimeter equal to how many, what do you call, in x-axis what you are representing, time, right? How many seconds? Say 5 seconds. And in y-axis 1 centimeter equal to, what you are representing in y-axis? You are representing position, right? So in y-axis 1 centimeter is equal to, again say 5 meter. So in this page there is no space, so I'll just show how to write that values on the x and y axis. So here I'll rub this, yes. How I can represent along x-axis? See, 1 centimeter equal to 5 seconds, right? So here, starting from 0 at the origin, here I have to write 5, then I have to write 10, 15, 20, like this it will continue, right? That is how we choose scale. 1 centimeter equal to 5 seconds, right? So 5 second increment should be there in, up to the end, right? So that is how we represent. Then along y-axis we represented position. So position means how we taken, it is 1 centimeter equal to 5 meter we have taken, right? So again we have to write here 5, 10, 15, like that it continues. Okay, so I think you understood how to represent the values along x and y axis. Now I will rub these things in order to draw the graph. Okay, as there is no space here. Yes, carefully look at it. So when time is 0, that is position is 0. That is, you have to put a point at the origin itself. Correct? At the origin. Exactly at the origin, the starting point is there. Then after 5 seconds, when it is 5 seconds, the position is 5 meter. That is, the distance traveled is 5 meter. So where you have to put the point? That is, the time should also be 5, and also the position is 5. Correct? So you have to put a point uh, here. Okay, so I'll put a point there. Here I have to put a point. Second point. Then third point. When it is 10 seconds, 10 meters. Position is 10 meters. So again I have to put a point that comes in between like this. So here I have to put a point for that. That is here. Okay. Then I can join them with a straight line like this. Okay. So this is the graph representing position and time for the given values. For the given values. Okay, this is how we draw the graph. And then one more important thing that you have to remember here is how to take the slope of the graph. Slope of the graph. For doing that, what we do is we will draw a right angle triangle somewhere in the graph. Okay, like this, right angle triangle, such that hypotenuse of the right angle triangle is included as the line that we draw. That should be the hypotenuse. Okay, its part should be the hypotenuse. It may be of any size. The triangle may be of any size. Don't worry about the size of the triangle, but it should be right angle triangle. Okay, that is here. Angle should be 90 degree. Then we will name it as A, B, C or anything. X, Y, Z, A, B, C. Okay. So how to take the slope of this then? This is the first step in order to take the slope of that. So I will write that in the next page. Okay. Slope. Slope of the graph. Slope equal to, I will write the formula first. AB into that is y scale. Y scale is that we have chosen first, right? And divided by BC into X scale. These are the values we have chosen first, right? So here what we have to do, we have to measure AB using scale, how many centimeters it is. We have to measure this much centimeter. And then we have to measure what is BC, this length BC, its length in centimeter we have to calculate. That we have to write here. In place of AB and BC, we have to write those values in centimeter. Then we have to multiply y scale. Do you remember what we have chosen y scale as? Y scale, along y scale, y axis we represented position, right? So 1 centimeter equal to 1, that is 5 meters we have chosen. So we have to write 5 here. Is it okay? Okay. Then into x scale, that is, we have chosen time there as 5 seconds. 1 centimeter equal to 5 seconds. Okay, and again 5 here. By calculating this, we'll get a value which is slope, which is a slope. So what is the slope here? The slope is equal to what here? So what you get in the numerator of this, what you get here, that is some value into y scale. What you represented on y axis, that is position. So when you are multiplying this, when you are doing this, you will get some value which is position or distance, displacement. Okay, you will get some displacement value in meters. And when you calculate the denominator, this along x-axis, what you represented? You represented along x-axis the time. So when you multiply some value with that 5 seconds, you will get some seconds, that is time. So what you have here is actually displacement by time, x by t. It is x by t, displacement by time. That is rate of change of displacement. What is that? That is nothing but velocity or average velocity. So we get average velocity from the slope of position time graph, xt graph or pt graph. Okay, so from position time graph we get average velocity. That itself is explained here in this page. Okay, see, average velocity from pt graph, position time. Okay, so this is how we'll get average velocity. Don't worry about these lines. These lines are for understanding how to get the slope. Okay, I explained that already, so don't worry about that now. If we want the average velocity of the object between x1 and x2 in the graph, we have to take the slope of the line p1, p2, which will be equal to average velocity. Okay, see, I have given one example here, that is I have taken a simple example, right? That is, this line is straight line, but in this given uh, picture the graph is not straight line, it is a curve. That is why some difference is there. That difference I will explain in the next video. For the time being, I think you understood the simplest case. And you just remember, slope of position time graph gives average velocity. Average velocity. This much you remember, and I'll explain what is the difference in this case in the next coming video. Okay.